Sorry for that, leaders. I always forget these things of recording. Sorry for that. It was not intentional. It's a mistake. Can you see the plot? This one, remember, we're having two independent variables. The first one is between the other independent variable is size, and the other one is age. Now, maybe just to give you a brief information on what is happening with this data set. This data set, you have two variables, which is the size, the age, and the price. What is happening here? There's someone who want to buy a house. You want to buy a house. Buy a house, but you want to estimate. You want to buy a house. Obviously, immediately when you want to buy a house, you're going to use what? Money. Leaders, there's someone here. Please, leaders, the reason why we don't want to close your mics is because you don't want to treat you like slaves. So also do the same thing from your side. Control your decisions. You cannot just open the mic so that we can hear you that you are laughing. It's not professional. Let's be professional leaders. If you know that your mic is on, it's possible that it can be on by mistake, but don't do it deliberately. So I will assume that the leader who was laughing a few seconds ago is not deliberate, it's a mistake. Let's continue. As I was explaining, this person want to buy a house. Obvious, money is involved, isn't it? So you want to know the price of the house based on how old is that house and how big is the house. So let's get this right. How old is the house and how big is the house? How old, it means is the age. But there's a question that I expect you to ask me. That when you're talking about how old is the house, which measure are you using? Is it in month? That 30 represent what? You are supposed to ask that question. The 30 represent that the house is 30 years old. So it means you are X2, the age is in years. The age of the house is in years. That 32 there, let me go back to the price. The 32 there is 32,000. It's not 32 rands. It's 32,000. That house. So same applies to the size. It's very, very important for you guys to know the units. Remember the definition that I gave you in the morning? I said y is expected to change when the dependent variable is increased by 1 unit. So you must know the units of your variables, because that unit, you will need it when you are interpreting the betas. So if you don't know the unit, it means you'll have a challenge when we try to interpret the betas. Get that one right, leaders. Units are very, very important when trying to explain something. So the price is, I think, is there also there from your study guide, that X1 is measured in what? X2, the unit of X2, and the unit of Y. So now, let me go back to the scatter plot. So now, you see the price there, the price is Y, and the size is X. What can you say about the relationship that we see there? If you want to say it out, please raise up your hand for control. If you prefer writing, we can simply write from the charts. Yes, leadership, Homu.
So if I said there's a positive linear relationship between price and size, am I wrong?
Thank you. Another one. Do you agree with what Mr. Homu said? Do you agree or disagree? Mr. Homu, can you please repeat your statement?
A positive linear relationship between price and size.
Yes. Please get it right, guys. He's talking about a positive linear. If we just say there's a positive relationship between X and Y, there's something wrong. Because you must indicate the relationship that you are seeing there. If it is curvilinear, be specific that no. There, I suspect we're having a curvilinear relationship. So let me go to the other one. So from between X and price and size, you suspect a positive linear relationship, but you cannot say that you cannot tell the strength at this point. You only tell the strength by having what? By running or calculating the correlation coefficient. That's why you can tell if that linear relationship is positive or is it strong, is it weak, is moderate, and so forth. So let me go to the other variable, which is now the age and the price. Let me run the scatter plot. Please, for this one, give others a chance. Give us a chance to answer. I'm running the scatter plot. Yes, another one. Now this one is between price and age. Oh, this one is wrong. Price and age. What can you say about this relationship? Omu, you cannot be the one answering the question. Give others a chance. Leaders, a scatter plot between a price and age. What can you say there?
So there
Yes.
is no multiple linear relationship between the age and price.
Why are you talking about multiple?
Hmm? Oh, why are we not testing between several variables?
No, 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 no. Remember, if you can check, you are running a scatter. This, whatever you see here, it has nothing to do with the other variable. This is the relationship between price and age. So you are checking the relationship between the two. You cannot talk about the other independent variable because it's not affecting what is happening here. Anyone want to try? Thank you for trying, leadership. Another person want to try?
Okay, so it means that there is no relationship between the age and the price.
Leadership, there's something missing there. I hope.
Oh, so there is no linear relationship between the age and the price.
Thank you. If and next time leadership Smanga, do it in the form of hands. If you want to say something, please raise up your hand for control, please. He's right. There is no. This is a visual inspection, isn't it? Based on what is inspecting, you suspect that yes, it seems like there is no relationship. You cannot tell the price of the house. How much will the house cost based on the age of that house? That is what Mr. Smanga is saying. He's simply saying that no, if you can give me the age of the house, I don't think that age of the house will be able to help me to predict the price of that house. But when you check the other one, the other variable, which is x1, the size, this one, it seems like if you can give me the size of the house, I'll be able to estimate what the price of the house, given what the size of the house. But when coming to the age, it seems like it's a different story. When if you can give me the age of that house, I don't think it will be easy for me to predict the price. But this is just what a visual inspection. We'll see it as we continue. If indeed, remember, we're doing statistics here. We can only rule something out by doing what? In the form of testing. In the form of what? We need the proof. So now, let's go to our problem, the morning problem. Let me share the other one now. So I gave you a task to go and where's my notes now? I gave you a task, guys, to go and solve that problem. I hope now you have answers. Oh, it is here. It's fine. Let me share the screen. How far are you with my task? Oh, it's coming. It's coming. The shared note is coming. How far are you with my task? I asked you to go and find x prime y and the inverse. X prime y and the inverse. What did you find, please? Stuck on finding beta, but do you have the inverse and x prime y leadership, Christopher? Leadership, Christopher? Can you please give me the matrix of x? Can you give me the matrix of x, please? Yes. I remember 20. Give me the matrix of x. What the answers that we have for matrix of x?
It's 1, 1, 1, ellipsis
No. X prime x. X prime x. X transpose x.
20, 40,
20.
oh, 40,
Yes.
430,
430.
Where you are is 93.56. Oh, there's 40.
Yeah. Yes. What?
93.56.
On this side.
844.7.
844.7.
Yeah.
Okay. Thank you. It means, guys. It means you guys didn't do my task. So now you're giving me a yes. What?
10,990.
Since you guys didn't do my part. Is it true? Guys, he didn't do my part. Y inverse of the inverse of x prime x is given by I'm going to give you the inverse now. Can you please confirm your values? Is your inverse values the same as this one? Those who didn't find the inverse, yes, the inverse, but it's your responsibilities, guys, to go and find this information. Let me increase the font. Let me make it 12. Yes.
So, sir, I want to understand you, sir. Since you are using Excel, I want to understand ourselves during the test. Are we going to use formulas, or as we are required only to interpret what you got from maybe Excel or SAS or SPSS?
No. Finding the inverse is you must know how to find the inverse. It's your responsibility, leadership. It's mathematics. You are expected to know how to find an inverse of a 3 by 3. I can only help you to find the inverse of 4 by 4, 4 by 4 matrix plus. But how to find an inverse of a 2 by 2 matrix and 3 by 3 matrix, that one, I will advise you to know it. But if it's a 4 by 4 matrix, I know it's a lot of work to do that. I can help you with the inverse. Did you hear me, sir?
Yes, sir.
Thank you. So please, for those who didn't find the inverse, here's the inverse of that x, the matrix x of prime x. So please copy it if you don't have it. Copy this one. Inverse, remember, is from the questions. This is one of the questions that I asked you to go and do. I don't know if you managed to do that. The inverse. Copy the values, please. Those who didn't do it, copy the values so that we can move. So you only copy this one and don't copy the other part. This is the inverse. This is the inverse. Whatever I was doing there is the procedure to find the inverse using Excel. So you just have to copy this information because we'll be using this information in most of the cases. So please make sure that you copy this information. Because this was the only part that was remaining there. And now we have to move to the betas. How do we estimate those parameters? Beta 0 or beta 0 hat, beta 1 hat, and beta 2 hat. Now with this inverse, are you done copying? Are you done copying, leaders? Yes, Omu.
Said the inverse, that inverse matrix. So you expect it to be like that. If maybe I round it off, it might be wrong.
Yeah, if you round it off, it may affect some of your answers as you continue. You may start getting negative SST, negative S. Remember that on the ANOVA table, you don't expect negative values, isn't it? On the
Yeah.
ANOVA table, we're talking about sum of squares. But if you start rounding some values at an early stage, it may affect your calculations, and then you start getting negatives. And then
Oh.
you'll be surprised, why are you getting negatives? Because you did everything right. And you find that the reason why you're getting negatives is because of rounding these values. So don't round them. I'll tell you a stage where now it is safe to round them. But at this stage, when you're finding the betas, don't round the values. Don't round the values. Even the values of the betas, you write them the way they are. If it's having 10 digits after the comma, write the 10 digits after the comma. This also applies to the betas. Inverse, you don't round the values off. When after finding the betas, you don't round them off. You write them the way they are. If it's 10 digits, write those 10 digits. So if you want to bypass all these problems, write the values in the form of fraction, in a fraction form. You said you're done copying. Let me go to that document now. Or let me just go to whiteboard because you have the inverse and you have. So now let's find the betas and try to interpret them. I didn't forget the question that I was asked by leadership concerning the increased part from the statement. Oh, sorry. Let me write the formula. Christopher? Chris?
Yes, sir.
Yeah, don't mute your mic, ne? Don't mute your mic. I want to understand which parties you feel
I'm
should
fine.
apply. You have x prime x. This is what?
I
This
got
one,
it, sir.
Christopher? You got it, ne?
Yeah, I got it.
Who was the other guy? Who's the other person who was asking that? He was saying they feel they are stuck in this section. Someone said I'm stuck. You have this matrix, guys. You have this matrix, which you said is what? You said is 690. Can you please give me the values? I think it's
1554,9.
155.
Yes, 1554.
4, yes.
0.9.
0.9. Second one,
145.
145.
40.
40. No decimals.
Yes, no decimal.
So you have the matrix now. This is the inverse, isn't it? We have the inverse now. You multiply the two. Now start multiplying the two. Let's start multiplying. It's fine, Chris, if you said you got it. Here you have what? Inverse. You just calculated the inverse now. Inverse. Multiply the inverse with this matrix of x prime y. What are you getting? You multiply the inverse. Then the first value that you get is a, which is the same as beta at 0. The second value that you'll get there, Christopher. Chris? Chris, check your mic.
Oh, sir,
Yes.
I wanted to give you the values.
Yes, please, please.
The first one is 10,046.
The first one is, let me write it. I repeat, Christopher, you give me the value the way it is. If it's having a lot of decimals, you give me with those that value with those decimals.
Okay, let me. It's 10,
Yeah, with the decimals,
0,
everything. You don't round the value of. You write the value the way
10.
it is.
Okay,
I
it's
want
10,
to write them. Yeah. Equal to the first one. I think is what, Christopher?
10,046. 34.
10.046.
46.
Yes.
34.
34. That's all.
Yes.
The second one,
12, 83,
12
4,
comma,
83,
yes,
445.
445. The third one,
Negative
I
0,
hope you're not rounding the values off, Chris.
yes.
Okay, the last one,
Negative 0,05.
0.05,
652.
652.
Yes.
These are the values, guys. Now let's write the model. Let's write the model the normal, the normal way you know how to write the model. So we'll have what? Price, price. A cap is very, very important. If you write a model without that cap, is wrong, and you'll be marked wrong. Plus 12.83 445 x1, x1, which is size, minus 0.056. You write all the values, x2. This is the model, guys, that we have now. So we assume that using, yes, Christopher,
So what if I say XI1 and XI2?
is fine. It's not a problem.
Mm,
Yes, not a problem. Because if even I think that one is the correct one, because you'll be able to replace, isn't it, whenever you are asked to estimate. When I say estimate using I1 7, you know that is the first row, is the first column. That one will be what? I2 will be what? I7 it means row, and then you said you write what? It seems like I agreed something that you said it what? I what? I1.
XI1, yes.
I1. Yeah, it's fine. If X I1 is fine because um, let me let me use a different color. You're definitely correct, leadership, because X I1, the one that will keep on changing is the X part because it's the row, but the column will remain the same because we are dealing with what? Variable at first column. So it's fine. I is the one which will keep on what? It will keep on changing. I11, it means first row, first column. I X71, it means it's row number 7, but still first column. Yeah, you are right, leadership there. Thank you for that. So now we have this model. Remember, I said X1, which is the size, is measured in what? It's measured in is the what is the size, isn't it? Size is what is measured in what from the study guide. What I can recall is that price is in thousands, age is in years. What about the size, the x1? X1 is in what? What is the unit of x1 from the study guide?
No information, sir.
Sorry?
There's no information.
There's no way. Are you sure, Chris? Let me go there. Let me go to the study guide. Oh. Yes? Yes, leaders.
Who say it's
Yes.
measured in thousands of square feet?
Square feet.
Yes. Thank you very much. X is in thousands of square feet. X, sorry, size. Thousand. It's very, very important to know that unit, because according to the definition, you will need what? You will need that unit. So now let me go back to what one of the leaders asked earlier. She asked me that I will always increasing. Now let's go to that section now. I will always increasing. Let me go to the part. She was right there for asking that question. In the morning, I said, I repeat, the regression coefficients BIs measure the change. Let's understand this statement. Even if we take 10 minutes trying to understand that statement, I don't have a problem. BI measures the change expected in the expected response of Y. What type of a change are we talking about there? How can Y change? What type of change are we expecting from Y? This is just a general statement. Ne? The change that we are referring to is that Y can decrease or increase. We cannot tell, isn't it? We cannot tell if Y will decrease or increase without solving the problem. Now, we have our beta 1. Our beta 1 is positive, isn't it? Can you hear me, guys? Our beta 1, which is 12.83 something there, is positive. So there we're expecting what? We assume that whenever we interpret this one, we'll say Y is expected to do what? When we increase that X value by 1 unit, or let me just write the value here. Now, when you're interpreting the coefficient, you can write them in short. But whenever you're doing some calculations, you use them the whole value. Matter when you are interpreting, you can shorten what the answer is fine. We said B1. Oh, sorry for the capital letter. B1 equal to 12.83. Sorry, 83 something. And B2 is negative 0.05. Something. That's fine. So, who was that person? Is it Matilda? Matilda, is it you who asked the question in the morning? Or let me write also the other one because it's also part of this. A equal to B1, B2. Matilda, are you here? And it's 10 point something, isn't it?
Yes, I'm here, but I have network problems. I'm not sure if.
Yes, no, it's fine. I you are the one who asked me about this statement of increase, isn't it, in the morning? But it's fine. I hope your network gets better. So we have these values, guys. Our beta, our intercept is 10 point something. let's go back to the model. The model is price. Price. Let me write it here. Price at 10.0 something plus 12.8 minus 0.005 The other one is size. H3 size. This is what we have, guys. This is what we have. Let me increase the font. This is what we have. So let's interpret the first one. Write it down. I'm not going to write this statement down. So let's focus on this statement. This definition is a general one, but we need to understand the definition. That's why I'm using different colors. We're saying the regression coefficient beta i's measure the change. The change, it can decrease, the value can, the price of the house in our case, it can decrease or what? Or increase. But it will be controlled by what? By the behavior of your beta, of your betas. So now, let me not start, and all other independent variables held constant. Held constant. Yes, leadership? I thought there's a hand.
So I think it's break. It's not break.
No, not yet. Hey, woman. It's supposed to be 1:45. I guess it's 45 minutes. Now you're killing me now.
Hey, sorry, sir.
Now you're killing me. Well. Yeah. So, guys, let's understand the definition. The regression coefficient beta i's measures the change. Measures the change in the response variable y when the experimental variable xi is increased by 1 unit. We're simply saying if we go to the edge of the house and increase the age of that house by 1 year. 1 year, because remember, age is measured in years. If we go to the age of the house and increase the age of the house by a year, we add a year, what will happen to the price of the house? Let's apply the logic. Manyama?
Like this example, myself, I've been trying to find, to locate this example you are doing now, but I can't find this example you are
From
doing.
the study guide.
Hey, I can't find it on my study guide.
Help the leader, guys. Help the leader. You speak which language? You speak Pedine.
Speak paid, sir.
Kendi.
But I understand
Kendi, help the
language
leader
inside
here.
of
Kendi is
flavor,
having
sir.
network problems. Yes, class rep. Open your mic. Talk to your brother. Use your language to talk to your brother.
We go page 40. Study guide this year, page 49.
Ask your questions, leadership. If you still need to have more questions.
Okay. I see it.
You are sorted.
Thank you.
Thank you, leadership. Thank you, Kendi and Ms. Class Rep. Thank you very much. So as I was explaining, we're saying, let's say our focus is on the edge of the house. let's say our focus is on the edge of the house. This part is on the edge of the house. So according to this statement, we are saying, what will happen if we go to the edge, to the unit of the house, and add one year? Remember, our age is measured in years in this case. If we can go there and add a year, we're simply increasing, isn't it? That's where I said it's always increased there, because you are always adding something. When you add that unit, what will happen to our y value? But holding the other independent variables what? Constant. So don't talk about these other independent variables now. Your focus is on what? It's on the edge, holding the other one independent. So you cannot talk about, when you're busy interpreting what? When you're busy interpreting the edge, which goes with beta 2, don't talk about the size, because size, you're holding it what? You are holding it constant. So let's go. How do we interpret beta 2, the negative 0.05? Yes, as I said, even if we take 10 minutes interpreting this, understanding this statement, I don't have a problem. Yes, leadership? Leadership, your hand was up.
Yes, so I think the price will decrease by 0.05.
Yes, let's put it nice. You are right, leadership there, but let's put it nice. Your beta 2 is negative 0.05. So let's start, leadership. When the edge of the house, edge of the house, which is x, isn't it, leadership, is increased, yes. Replace the one unit. Is increased by what?
By 1 year.
1 year. 1 year.
Then
the price of the house is expected to do what?
To decrease by 0.05.
To decrease. What is guiding you? Why are you saying decrease, leadership?
The negative sign.
The negative sign. The negative sign now is telling us that the price will decrease, but holding constant what? Holding constant the size of the house, isn't it, leadership?
Sorry.
Because you must hold the other variable constant.
Yes.
Can you please try the size now? Interpret the size.
When increasing
I'm
the
coming,
size,
Smanga. I'm coming, Smanga. Yes, leadership.
When increasing the size by 1, by 1, right? So the price will increase by 12.83.
Yes. Now there's something that you are eliminating, leadership. Smanga, your hand is up.
Break time, sir.
Okay, thank you. Let me explain this one before you go for break. I explained when we started that whenever you interpret the betas, the unit of whatever you'll be interpreting, I want to see it. I want to see it. We agreed that price is in what? So this one is the part where students, you guys, you don't want to do. Price is in thousands. Price is in thousands. Oh, sorry. Thousands. I think it's dollars there. Let me interpret one for you, and then age, the age of the house. The unit is in years. So the one unit is equal to what? It's equal to 1 year. 1 unit is equivalent to 1 year. That is the unit. And then we'll discuss this. So if this one, the price is in dollars, it means that we'll go for break. It means that 1 unit of $1,000, thousands is what? It's equal to 1,000. It's 1,000. The last one is the size of the house. We agree that this one is in thousands square feet. Sorry for that. Wait. 1,000 square feet, which means what would be the 1 unit here? 1 unit, it will be equal to 1,000 square feet. Please. This one is $1,000. So whenever you interpret these betas, we want to see these units. The outcome, guys, whenever you buy a house, you're going to use what? Money. So you cannot say when the age of the house is increased by 1 year, the price is expected to decrease by 0.05. 0.05 what? 0.05 thousand dollars. It's very, very important to indicate that part, that Y is measured in thousands, size is measured in 1,000 square feet, age is measured in what? In years. But we'll discuss it after the break. Let's go for break. We can come back at 1:55. Thank you. Those who don't want to break, you can start constructing that ANOVA table. It's Mang. Oh, thank
Yes,
you, Mrs. Mang.
it's me.
Thank you, thank you. Yes, what you are doing is right. You are paying for what you did in the morning. We couldn't have a break because you were not in. So let's understand it. Matilda, she's saying she's sorted now. She's saying she's sorted. But what about the other guys? I repeat, let's focus on the edge of the house. Let's focus on the edge of the house. We can start with this blue. What color is this one? What color is this one? Hey, these colors. Ladies, what is this color?
Pink.
Pinky. Someone said pink. This one is not pink leadership. I don't know colors, but this can't be pink.
Which word is that?
This second one, this last one from the definition. Is it blue?
Yeah, it's
Do we have a
blue.
blue? Yes. Let's start our statement with the blue color. Let's start our statement with the blue color. Yeah, it is. Write it down. I want to interpret this value. I want to interpret this negative 0.05. Yeah, or I can even. Yeah. I want to interpret that purple value there. That purple value. I will say, like, I want to start with this blue statement. This is what I'm going to say. Hey, leadership, now we are going far. We don't even know that color here. Holding constant the effect of size. Holding constant the effect of size. Now we see whatever I said, I have read, comma. For every 1 unit increase, in this case, it will be when the age of the house is increased by 1 year. When the age of the house is increased by 1 year, we expect the price of the house to decrease by 0.05 thousands of dollars. Let me repeat. Holding constant the effect of the size of the house. I'm interpreting that purple value. When the age of the house is increased by 1 year, we expect our price, which is Y, is our output now. We expect our price to decrease. Leadership, I think it's Christopher Manyama saw this. Manyama, he said we'll say decrease in this case because our beta there is negative. We expect our price to decrease by 0.05. Now we plug the unit of what? The unit of price. It will decrease by thousands, 0.05 thousand dollars. I think we have covered all the what? We have covered all the units because our focus, it was on the age and again on the price. Any question based on my statement? Any question? Please feel free, guys. Feel free. We're not in church here where you have to listen to the pastor preaching and then you are not saying anything. You must be free. Do you understand, guys? Or do you want me to repeat the statement again? I don't have a problem to repeat. If you want me to repeat, as I've indicated in the morning, My main focus is on you have to know on how to interpret what you have calculated. If you don't understand, if you cannot interpret what you have calculated, it means you don't understand what we are doing. So can I move to beta 0, the 10?
Yes.
There was a time when Mr. Chabala was teaching you that he said there will be cases where the intercept does not have a meaning. He said there will be a case where the intercept won't be having a meaning. So let's check in our case now. We will say when we don't have the age, the size of the house, and the age of the house, because now we're simply saying if we have an intercept model, suppose we have an intercept model, it means when we say we have an intercept model, we're only having beta 0, isn't it? When we don't have the size of the house and the age of the house, we expect our selling price of the house to be $10,000. Does it make sense? You don't have the size of the house, you don't have the age of the house, the age is 0, the size is not there, and the age is not there, but we are saying the price will cost 10,000. Does it make sense?
No.
No. So now we're in a case where we cannot interpret our intercept because in this case it doesn't have a meaning. But it's not always the case where the intercept won't have a meaning. There will be cases where it can have a meaning. So in our case here, the intercept, you must indicate that it won't make sense for me to interpret you must indicate that you wanted to interpret it, but when you don't have those two independent variables, the the price won't make any sense. You must indicate that no, in this case, you don't think the intercept is having a meaning because you give a reason there that if I don't have these two independent variables, I cannot predict the price. But there are cases where you can interpret the beta 0 even when you don't have those independent variables. So you will try the size, use the same procedure that we used. So you will try the size of the house. You will interpret the what? The 12,83. Try to interpret the 12,83. And then if you still have some issues, we'll discuss it tomorrow in the afternoon. But I'm giving you this chance to go and try to interpret the value. So based on the model, suppose we tell you that the size, we give you the what? We ask you to estimate the price when the size of the house is 2.2 square feet and the age of the house is 40 years. What would be the answer? When the size of the house is 2.2 thousand square feet and the age of the house is 40 years. Can you estimate that and interpret your findings? I indicated earlier that whatever you calculate, you should be able to interpret it. So I'm saying if the size is 2.2 square feet, 2.2 thousand square feet, and the age of the house is 40 years, what will be the price of that house? What will be the estimated price of that house? Someone is saying $20,000. Mr. Home is saying $20,000. What are you saying, guys? We are using the model to predict now. You can predict any size. Guys, what are you saying about Mr. Holmes? Home, how can you say I should repeat, but I have answered the question? I'm saying predict the selling price of the house, given that the size of the house is 2.2 square feet or 1,000 square feet, and the house that we are looking for is 40 years old. Now we want to estimate that if you need a house which is 40 years old and its size is 2.2 thousand square feet, how much will it cost? I'm waiting for the answers. We change this answer now. He's saying it's 36. Someone, Lamine, saying 18. Candy saying 36. Yes, someone, Tato and Tato Pasha and Matilda, they're saying 18. How did you get 18, leaders? You just got where the size and replace that size by 2,2. And where you see age, you replace that age by 40. What is your answer? They're saying 36. That's what it did the leadership. Can you please check your answer, Damini? I'm seeing the answers on the screen, but I don't. So far, only one person is right. No, two. No, it's only one. Michelle is the only one who's right. Michelle, you are right. The other guys are not right. Check the comment from Michelle. Immediately after Matilda. He's the only one correct here when I check the answers. Yeah, he's the only one. Why am I saying Michelle is the only one?
Sir,
So guys, you are getting to use the calculator. How did you get the 18.23, Matilda?
I said 10 plus 10 for beta 0, right? Plus
Yes.
the 12.83, and then I substituted the 2.2 for
Yes.
square 1,000 square feet minus 0.05, then I substituted 40.
You are getting what? Do it now again. Are you still getting 18?
Yes, I'm getting 18.226.
What could be wrong with the it's fine. Let me get another one. Thank you, leadership. Mwako. France. How did you get your 36,2260? Anyone from those who got 36,021? How did you get the value? Christopher, it seems like we have a solution. Who's right, Christopher? Chris?
Sir,
Yes, what's
yes,
your
what
question?
I say? I didn't round off. I just took the values as they are.
What did you get?
36,02133.
Did you hear what Christopher said, guys? You see now, the issue of rounding already now is creating problem. I said, whenever you want to use the values for calculations, use the values the way they are. But if it's for the issue of interpreting, you can shorten what? The values. You remember it, Matilda? Your mistake it was what? When I asked you to estimate, you forgot my statement that I said whenever you're doing some calculations, use the values the way
Yeah.
with those decimals. That is the mistake that we made, leaders. So those who got 18 were wrong. And now I said Malepe got the right thing. Now he's changing. Now he's also joining the other guys. He's giving me the wrong answer. Is it Malepe? The one who no Mashele. I said Mashele is right. Mashele is right because he's saying 36 thousands of dollars. When you say $36.22, you're not correct. Y is measured in thousands. That thousand should reflect. So when you say $36.22 is wrong. What happened to the thousand? So correct that. So let's move now. We move to the another one, which is the ANOVA table. So now that's what we're supposed to cover there. Whenever you have to interpret the model, focus on that statement there. This one when coming to the interpretation part. And then, but I said this statement, when coming to the increase by 1 unit, this is only applicable when you are dealing with quantitative variables. When we bring in the qualitative variables, that statement cannot be correct. But as we continue, you will see that. Now let's move to the ANOVA part. In the morning, I asked you to give me this information, the y prime, matrix of 1. So this information now is needed when you're constructing the ANOVA table. This information is very, very important. I won't repeat whatever is there. This is how why do we have to construct an ANOVA table? Why are we constructing an ANOVA table? Anyone? Why are we constructing an ANOVA table? I think if you can recall this question, I'm asking it for the second time. Last time I asked you to compare the difference between the t-test and the ANOVA table. You guys, you hesitated to give me the answer. Now I'm asking you, why are we constructing an ANOVA table? Why are we doing this test? What is the purpose of this test? Yes, Homo?
I think to test the relationship between the multiple variable, which is beta, those betas.
Yes. The importance of the test is to check if the relationship exists or not. Remember, the ANOVA table, we don't test for the direction of the relationship. For the global test is the ANOVA test. When I ask you to use the global test to check for the relationship, I'm simply saying use the ANOVA table to check for the relationship between y and those two independent variables. So I want us to do some calculations. If time is no longer on our side, we can finish it next week. It's not a problem. So based on the information that you have in the morning, we did some calculations in the morning. Let me go to the formulation. Let's check it, guys. Let's start with I know you guys, you said you like whiteboard. Let's check the first one there. SST. SST is given by y prime y. You know how to find y prime y minus 1 over n. You see, n there is not bold, which means we're not talking about the matrix there. We're just talking about the specific value of n. In our case, is 20. And the other part, this other part here, I said this part is equal to what, guys? This part, sorry, this one. I said this is equal to what? In the morning.
Summation
This
of
part
x all squared.
is what?
Summation of x all is all squared.
No. Anyone who want to try? Can't be summation of x.
Summation of y.
Summation of yi all squared.
All squared.
Summation of
So it
y
means
squared.
this is y prime y minus 1 over n. You have the value of y prime y, isn't it? You have the value of y prime y from the morning session. You have y prime 1, 1 prime y. You can get this information from the matrix of x prime y. This is summation of y, and you square the value. To find the summation of y, you can go to the matrix of x prime y. There's a part where you told me that you have 690. That 690, you square that 690, you will get this part. The same part is appearing here. Now, SSR is SS regression. The formula is what? You transpose the betas, you multiply those betas with x prime y matrix. You have this x prime y matrix minus this part is the same as, and the last one, this one here, it's up to you guys. But with me, usually I don't calculate this. I just do this. I don't use the formula to calculate SSE. I just take the difference, SST minus SSR. I know I'll find the SSE. But if you prefer using the formula, here is the formula to find SSE, sorry. If you can check, it's just the combination of these two, but these two, if you can check that the same, they will disappear, and then you'll be left with this one, this term, and this one. So let's do it, guys. Let me go to the whiteboard. You have the answers. Let's try to find that information. And then I will explain what we are testing, because that's what is important to me. Sorry, let me cancel this. Share whiteboard. So let's do it fast because we have the values. We have the values. SST, which is SS total. We agree that is given by y prime y minus 1 over n, y prime 1, 1 prime y. So when you are doing these calculations, there's no need for you to show me what you have substituted. Né? Give me the answer. Give me the answer for this one and the answer for this one. So what is y prime y? Let's do it fast. We have the answers. You can write on the chart.
476,100.
What is the question?
476,100.
Serrare, Tato. Tato. Yeah, let's go, guys. You are saying is what?
26178 minus
26178 minus 1 over 20
into 690
in brackets
squared.
Is what?
690.
Thank you. What are you getting, leadership? I'm told it's 2373. Can you please confirm the value, please? Can someone confirm? Okay, no, confirmed. Non-confirmed. Let's go to this one of this one. It says the matrix, the bit B matrix. Someone is getting 2737. Leadership, Mwako, check your answer. Is it correct or is it a typing error? Is what you're getting or is a typing error? They're getting 2373. You got to, or is an error? Thank you. Minus 1 over n. This part is the same as that one there. So here what you do, you have your matrix, the B matrix, but if you can check the formula, it says you must first transpose those values. The rule says you write the values the way they are from the calculator. Don't shorten those values, write them with all those decimals, because now we're doing some calculations. The other one is negative 0, 0.05. You write everything there. This is the transpose of y. And then you write the x prime y. This part now is this one that I'm trying to write here. You know the values there. Minus this part is the same if you can check. What is your value there? This one obviously will take some time to find the answer. Take your time. Wherever you don't understand, please ask. Philip, your mic is on. You want to say something? Tulare? Tulare? Maybe it's a mistake, but as long as it's not disturbing us, or I can mute this mic, it's fine. Someone got no, got 2261.42. Can someone confirm the value? 2261.42. Do you agree, guys? Can someone confirm the value? It means you are fast, Francisca. I'm asking for the value, but it seems like these guys are still busy. It means you are fast. So I'll only explain the degrees of freedom, how you get them, and we'll complete the other, because immediately I explain the degrees of freedom, you'll be able to complete what the whole ANOVA table. So tomorrow we'll just do the test. From there we move to what? From there we move to the t-test and explain why are we supposed to do the t-test. Can someone confirm the value from Matlow? Mr. Subula, do you mind to confirm the value for us? Mr. Subula? Thank you. If you can check the values from Francisca and No, they're not that different, but if you round the values off, there will be a big difference. So you have these two. Now with these two, you'll be able to find what? You'll be able to find your SSE. There is no need to use the formula in this case because you have SST, you have SSR. If you want to use the formula, it's just you just want to take a long dry. It will be like you are at gate, you want to exit the university, and you are at gate 2. You want to go to shop right, but you decide to go and use gate 1, and the shortcut is gate 2. That's what we'll be doing. So yes, you are sharing something, sir. SSE Francisca got 111.579. Are you cool with the value, guys? Saying SSE is 111.579. So the last part that we can do, guys, is to the ANOVA. The ANOVA now. I will only explain the first two parts. You'd have this the source of variation. Source of variation. You'll have the degrees of freedom. You'll have sum of squares. You have MS. You have F, like before. But here you'll have regression. Regression as before. Regression. And you have error. And you have total. This is what we have. Now, let's talk now. Let's talk about this one. Previously, from chapter 1 or simple linear regression, the degrees of freedom which go with the regression part, it was always 1. What was the reason? The degrees of freedom of regression, it was always 1 there. What was the reason?
We were only having beta 1 ohm. It was beta 0 minus beta 1 ohm.
I hear you, Homu. Can someone give me a different answer? Leadership, Malepe is saying we had 2 parameters. Because we had 2 parameters, that's what I wanted. Let's check the difference between. Can you see the answer from Aubry and the guys and Sibula and Tulare? Tulare, Sibula is saying because we're having 1 independent variable. That one is who? Is Sibula. Also supported by Tulare because we're having 1 independent variable, which is true. Let's check the answer from the other members. They said because we had 2 parameters. They're also correct. Because if we are having 2 parameters, it means it's 2 parameters minus 1 is equal to what? It's equal to 1. Someone will say, no, I didn't use this method of 2 parameters. I just checked the number of independent variables I'm having from the given problem. And then I just count my number of independent variables. I'll get the degrees of freedom there. The person is also correct. So there are 2 ways of finding what? The degrees of freedom of what? Of the regression. How many parameters do we have if we have to use Malepe's method or Ntweleng's method? How many parameters do we have in this case? We have 3. So if we use Ntweleng's method, so it means to be what? 3 parameters minus 1. The parameters is beta 0, beta 1, beta 2, which is what? Which is 2. It means the degrees of freedom of problem is what? Is 2. But let's not ignore what was said by leadership Sibula and Tular. They said, no, the method that we are using is a long dry. Let me show you the quickest method. Let me just go back and count how many independent variables I'm having. You have size and you have age. Now we counted. Size and age, 1, 2. They're not 2. So there are 2 ways of finding the degrees of freedom of the regression. N minus 1, you know this one. In our case, it will be what? It will be 19. Now, for the error, you find what? You find the difference. Or someone can say, no, I don't want to find the difference. I want to know where it is coming from. Is n minus the number of parameters. It's coming from where? Remember, to find the error, you say the total minus regression. So how do you get to this point? Is n minus 1, the degrees of freedom of total, minus, in brackets, p minus 1. So which is n minus 1 minus p plus 1. This one will go to Kimberly, and together with this one, you're left with what? N minus p. That's where the n minus p is coming from. But if you don't want to waste time, you are at gate 2, you want to go to shop right, you can simply exit using gate 2. But if you want to take long dry, you'll go and use the other 2 gates. So you'll say 20 minus 3 equal to 70. But the shortcut is what? 19 minus 2 is what? Is 70. Any questions? Any questions, colleagues? Are we okay? Thank you, leadership Damini. So, based on the given information, you can go and complete this ANOVA table, because you have the degrees of freedom, you have the sum of squares, you can complete the other sections. The same procedure that you used when you're dealing with simple linear regression. But the question now which will remain is that, what are we testing? What are we testing in this case? Yarn null hypothesis. There were 2 students in my office earlier, around 11. I explained this section. Whenever I ask you to write the hypothesis, you have to write the statements in weight, not using mathematical expressions. Write the statements in weights. What will be our null hypothesis? What will be our null hypothesis? From there we knock off. Null and alternative, and then we disappear. What will be our null hypothesis?
Sir,
Yes.
I think it will be there is no linear relationship between the x variables and the y variable.
Correct. There is no, let me get it right. There is no what?
Linear relationship.
Thank you. Thank you very much. There is no linear relationship between the y and those 3 independent variables. You are simply saying, mathematically, you are simply, but I don't want this. B1 equal to B2 equal to B3 equal to 0. That's what we are saying, leadership. There is no linear relationship between the y and the 3 independent variables. So what about the alternative? What about the alternative? And from there we disappear. Alternative hypothesis. Anyone want to try the alternative hypothesis? It's there from your study guide. But let me help you, it's fine, because time is no longer. Yes, Omo?
Can you say at least one beta diff?
In not that one is mathematically. Can you please give me the statement, not in a mathematical expression?
Sir,
Yes.
the alternate hypothesis is there is a linear relationship between the independent variables and the dependent variable.
Something is wrong there, leadership. Because immediately, leadership, let's check. Whenever we are saying there is a relationship between the dependent variable and the three independent variables, that one is not correct. Leadership, Pumulo. There's something missing there. Pumulo?
So the alternative will be there is a multiple linear relationship between the independent and the dependent variable.
Leadership, lead class rep is saying there is be a multiple. So again, something is missing. Something is missing. Christopher, let's go.
Will
That
it
one,
be
Refilo, is a mathematical expression. I need you to write that statement, not mathematical. I don't want a mathematical expression. I want a statement which involves the dependent variables, variable and the independent variables, not the betas. Yes, Lisbula.
There is a linear relationship for at least one independent variable and the dependent variable.
Yeah, it's almost correct. It's almost correct. Most of the things that you guys were missing from Mr. Sibula's thing is answer is there. Yes, is it Sibula again? Is it Sibula again? Matilda, your mic is on. You want to say something? Immediately you get this one right,
Yes,
we
I
knock
want
off.
to try, sir.
Yeah, try.
There is
Wait,
a
Manga, you want to try?
there is a there
Yes,
is a linear relationship between y and at least one of the independent variables.
variables, isn't it? What Matilda said is correct. What Matilda said is correct. Yes, yes.
Ehleketa ya endli mani nkarhi wu helini.
Hey, Smanga, I ruled on that one. I said, get this one correct. From there, we knock off. Linear relationship between the independent variables. Let me check what this
So,
leader said.
sir, what
You are
about
talking
if
about independent and independent leadership. Check your statement there. Yes, leader. Check your statement. You are saying independent, independent. Who's talking? Let's get this one right, guys, and go. Who want to try? Can I get this person to try, please? Correct. What leadership Malepe wrote is correct. There is a linear relationship between the dependent variable and at least one of the independent variables. At least it can be one, only one, or it can be, in our case, it can be. It's possible that we can only have a relationship between y and size, but we find that there's no relationship between y and age, or there's a relationship between y and age, but there's no relationship between y and size, or there is a relationship between y and the two independent variables. So now, when we move to the t-test after doing that, if provided we reject, when we move to the t-test, we will check, we will be tracing if all the independent variables are important in predicting the dependent variable. And what did I say if the one of the variables, after using the t-test, the variable is not significant? What did I say about the variable? If the variable is not significant, what will we delete it? We can drop the variable because it is not helping us in predicting what? In predicting the dependent variable. I thank you. Let's meet tomorrow. 3 o'clock. Let's make it 3 o'clock. It's fine, Homo, you can remain behind if we have questions. The other guys, if you want to go, you can go, it's fine. So let's meet at 3 o'clock tomorrow, not for 14:50. Let's start that one at 3 o'clock. Was supposed to be a tutorial. I just want to finish a certain section before you go for recess. So tomorrow we'll do the hypothesis testing for this one, the ANOVA table. We check our conclusion if it leads us to the t-test. We don't just do the t-test, we do the t-test guided by the ANOVA table. Whatever the ANOVA table is saying, it will guide us to move to the t-test. So that we must know when is it necessary to do the t-test. It's not always the case that we have to do the t-test. I thank you. Enjoy. Mr. Omu, you can remain behind.